Hello! Today we will show how to perform image analysis according to the following article by Hraničarová-Horáková et al., which title you can see here. It involves nucleus, nucleoli, and chromocenter segmentation and evaluation of HP1 protein content using computation of expected intensity. Let's open the depository of HP1. And browse the VOIs. We can see 8 images in our depository. Firstly, we segment nucleus. So go to Plugins, Segmentation, and find Objects by Edges. We will compute on blue channel, at this one, on a whole image, and name the output group as Nucleus. Gaussian filter here with these parameters will smooth the image a little bit and attenuate the noise. In main, use these parameters that won't be combined with Laplacian. And in post-processing, use hole filling, slice by slice, and basic morphology, especially erosion, with this parameter that reduces the surfaces on the perimeters of computed objects about 0.3 microns. These settings correspond to those in the article mentioned before. Let's look at our group Nucleus. Here you can see the output, which nicely covers the nucleus. It meets our requests. Secondly, we segment chromocenters. We will use the method of hysteresis thresholding. It's here. Name the output group as chromocenters. And let the algorithm run on the nucleus channel. It's this one. And change the input to nucleus we've just computed. In pre-processing, use Gaussian filter with these parameters. And use log-odds method. This logarithmic method increases the success rate of threshold determination, especially when the number of high-intensive voxels belonging to chromocenters is low. If this does not help, we recommend increasing the number of expected levels. Object level controls what intensity level to choose as threshold. The higher value, the brighter objects will be segmented. Let's use 2 levels for all our images and keep the settings of removing small lumps after thresholding. Our parent mask is Nucleus, which we selected as the input group. Here you can see 4 options that specify how to operate with the mask. First option, it's here. We'll take only objects completely covered by the 3-dimensional Nucleus mask. Second option, we'll crop found objects by the mask. The other 2 options are complementary to these first 2. We choose option number 2. And use size filter with these parameters in post-processing. These settings also correspond to those in the article. Let's look at our group chromocenters. Type V, Ctrl G, and select chromocenters. Choose color, for example yellow, and show the boundary only. We can switch off the red and green channels. This is better. And use page up and page down keys to go to another image. Notice the unsatisfactory result in 4 images starting from the third one. Let's recompute these 4 images from the third one using the same output group, with the only difference, and it's incrementing the number of expected intensity levels of the images. Former information of the 4 images will be replaced with the new ones. Look at the output now. It is definitely much better. We will keep it that way. Let's move on to nucleoli segmentation. We will use hysteresis thresholding again. Name the output file as nucleoli. And change channel to the red one, the nucleoli. But the input group stays nucleus. We will use the same parameters for Gaussian filter as before, and standard odd-sum method with 2 levels will work well here. Keep the parent mask the way it is, and here in size filter change the minimal volume to 500 according to the article. It removes objects smaller than 500 voxels. Let's look at our output. Press V, Ctrl G and select nucleoli. Show the boundary only and change the color to yellow. Switch on the red channel. You can see our segmentation is correct and we are satisfied with it. So we finally come up to our last part, and it is HP1 content evaluation. We want to study the most frequent intensity value of HP1 channel in the volume of nucleoli and chromocenters. Let's show how to compute it for nucleoli. Go to Plugins, Statistics and Expected Intensity. Our parent group is Nucleus, subgroup is nucleoli, the channel is HP1, and the window size is 5 according to the article. Now just type the name of the output text file. Now we should repeat this last step for the group of chromocenters instead of the nucleoli. But I believe you can easily do it yourself. Well, thank you for your attention and wish you a nice day.